Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and today we are going to see previous year questions. So in this lecture, we are going to study previous year questions on averages. So let us get started with our first question. The average of series 500, 505, 515, 530, 550 is. So the concept that will be used here is average equal to sum of observation upon number of observations. So the observation that was provided here is 500, 505, 515, 530 and 550. And if you take the sum and divide it by 5 because there are 5 observations, we will get 520. So the correct option here will be 520. Moving on to problem number 2. What is the average of first 57 natural numbers? So now try to recall the formula that we have studied for average of first n natural numbers. So that was n plus 1 upon 2. So now here in this question n is given to be 57. So the average will be 57 plus 1 upon 2, that is 29. So the correct option here will be option number B, 29. Moving on to problem number 3. The sum of 10 numbers is 686. What is their average? So we have 10 numbers and their sum is given to us and we are interested in finding the average. So the average is given by sum of observations upon number of observations. So in this case, the sum of observation is already provided to us, that is 686. So the average is going to be 686 upon 10, that will be 68.6. So the correct option here will be option number C, that is 68.6. Moving on to problem number 4. What will be the average of all the even numbers between 5 and 29? So here all the even numbers lying between 5 and 29 are 6, 8, 10, 28. So it goes on till 28. And in this case, the best way to do is to use the first plus last term upon 2. That formula will be very helpful because if you go on finding the sum of these all numbers, it is going to be time consuming. And when you know that when the difference is common difference is same, the difference between the sequence is same, so it becomes an AP, and when it is a AP, I can use this formula to find the average. So the average will be first number plus last number upon 2. So the average will be 6 plus 28 upon 2, that is 17. So the correct option here will be D, that is 17. Moving on to problem number 5. The average of 5 consecutive natural numbers is 43. The largest of these number is. So we are provided with 5 consecutive natural numbers. So notice that the 5 numbers, these 5 numbers are not first 5 natural numbers. They can be any 5 natural numbers, but these are consecutive and their average is 43. So what is the largest of these numbers? So now try to recall that when we have odd number of terms, then the average is the middle term. So we are provided that the average is 43 of these 5 consecutive natural numbers. So the average is 43. That means the middle term is provided to us secretly in the question. And since the middle term is known, you can easily find out what are the left terms and the right terms. Okay, and since they are consecutive, the right term will be 44 and 45, and clearly the largest one is the 45. So the option correct here will be option number C, that is 45. The average of 5 consecutive odd numbers is 37. What is the sum of highest and the lowest number? So highest plus lowest number is equal to average into 2. So that will be 37 times 2 equal to 74. So the correct option here will be option number B, 74. The average of 7 consecutive odd numbers is A. So we are provided with 7 consecutive odd numbers and their average is A. If next 3 and previous 2 odd numbers to these 7 odd numbers are also included, then the new average of these 12 odd numbers is. So the hint for this question is, when we add or subtract 1, 2, 3 consecutive odd and even numbers, then the average will be increased or decreased by 1, 2, 3 only. So the average of 7 consecutive odd numbers is going to be A, correct? So next 3 and previous 2 odd numbers to these 7 odd number included, then the average will be increased by 1. So the new average of these 12 consecutive odd numbers is going to be A plus 1. That is option number A. Moving on to problem number 8. What is the average of prime numbers between 12 and 25? So I hope you remember what are prime numbers that we have already studied in the series of number system. So the prime numbers between these two are 13, 17, 19 and 24. And now we have to take the sum and we have to just divide it by 4. So the sum of 13, 17 and 19 and 24 is going to be 72. And when we divide it by 4, we will have 18. So the correct option here will be option number D, that is 18. What is the average of first 4 multiples of 6? So we need to first identify what are the first 4 multiples of 6 and then we can take the average. So the first 4 multiples of 6 are 1, uh, 1, 2, 3 times of 6. So it will be 6, 12, 18 and 24. And since 6 is common among all these, to save time, I take 6 common and write it here. Because if I have to add 6, 12, 18 and 24, it is going to take more time as compared to adding 1, 2, 3, 4. So it's a very fast way to do that. So when I do that, I will have the sum of these numbers to be 10, correct? And 6 is here and you can like cancel them. It will be 3 and 2. So on simplification, it will be 15. So the correct option here will be option number D, 15. Moving on to problem number 10. So if 26A plus 26B is given to be 234, then what is the average of A and B? So to find the average of A and B, either you need to find A and B, because ultimately you are interested in A plus B upon 2, and until you find A plus B, then the average cannot be obtained. So you have 26A plus 26B equal to 234, and you can take 26 common. You will have 26 times A plus B equal to 234. And on simplification, you will get A plus B equal to 9. So the average is going to be A plus B upon 2, that is 9 upon 2, and it will be 4.5. So the correct option here will be option number B, that is 4.5. Let us move ahead to question number 11. The averages of 10 numbers is 42. So we have 10 numbers and their average is given to us, that is 42. So if each number is increased by 5, then what will be the new average? So each number is increased by 5. So that is the key point here. And now try to recall the concept that we have studied while solving the questions. Whenever observations are increased by a particular number, suppose A, then the average also get increased by A. So exactly same is going to happen here. So each number is increased by 5, then average will also be increased by 5. So the new average of 10 numbers will be 47. So the correct option here will be 47. Moving on to problem number 12. Average of 11 numbers is 8. If every number is tripled, then what will be the new average of numbers? So we have 11 numbers and their average is given to be 8. And now every number is tripled. That means each observation is multiplied by 3. Then what will be the new average of these numbers? So now try to recall the concept that we have studied. According to that, when we multiply each observation by some number a, then the average is also multiplied by that number a. So the average, every number is tripled, then the average will also be tripled. So the new average is going to be 8 times 3, that is 24. So the correct option here will be option number B, that is 24. The average of 24 numbers is 43. So 24 numbers are there and their average is given to us, that is 43. So if we subtract a number m from each number, then the average becomes 38. Then what is the value of m? So in this question, we have 24 numbers and their average is 43. And each entry, each observation is subtracted by some number m. So the average became 38. So what is the value of m here? So that is what we are interested in. So the average of 24 numbers is 43. And if you subtract each number by m, then the average becomes 38. And now try to recall, whenever each observation is changed by some a, if we subtract each observation by a, then the average is also be subtracted by a. So the same thing is happening here. So the average will also be reduced by m. So we will have 38 equal to 43 minus m. So m will be 43 minus 38, that is 5. That means we actually reduced each observation by 5. Then our new average become 38. So let us move ahead to question number 14. In match, average runs scored by 4 batsmen is 48. So in a match, 4 batsmen scored on an average 48 runs. And if the runs scored by 3 batsmen are 58, 28 and 24, then how many runs did the fourth player score? So there is a match going on, cricket match, and 4 batsmen, average run scored by 4 batsmen is 48. And if I provide you with the runs scored by 3 batsmen out of 4, then what is the run scored by fourth batsman? That is what we are interested in. So the fourth player scores will be equal to 48 times of 4. So here we have used the formula, that is sum equal to average into number of observations. So 48 is the average, 4 is the number of batsmen. So 48 into 4 gives you the total runs scored by these 4 batsmen. And the individual score of 3 batsmen is already known to you. So the total score is 48 times of 4 batsmen. And this is the total score of 3 out of 4 batsmen. So if you subtract them, this is obviously going to give you the score of fourth batsman, that is 192 minus 110, that is 82. So the runs scored by the fourth batsman is 82, that is option number B. Moving on to problem number 15. The average age of 6 brothers is 15 years. If their father is also included, the average age is increased by 7. Then find the age of father in years. So let us suppose the age of father be X years. So the average age of 6 brothers is 15 years. That is already given to us in the question. So according to the question, 6 into 15 plus X equal to 7 times 22. So this is the same question, similar question that we have studied in the previous part of the average lecture. Okay, so here the formula that we are using is sum equal to average into number of observations. So there are six brothers, and 15 is their average. So 6 into 15 gives their total years, and adding x gives you the sum of years, including father and all the six brothers. Okay, and 7 is total number of people. Okay, and the earlier age was 15 and it increased by 7. So 55 plus 7 is 22. So this is the same thing that is written on the left side. So we can equate them, and on solving you will have x equal to 64 years. So the father age is 64 years. So the correct answer here will be option number C, that is 64 years. Let us move to problem number 16. The average age of six members of a family is 20 years. So there are six members in a family and their average age is 20 years. So if the age of servant is also included, then the average age increases by 20%. Then what is the age of servant? So there is a family of six members and their average age is 20 years. And now, when I include the age of servant also, the average age of those seven members increases by 20%. So they have secretly provided you the average age of seven people, correct? And now they're interested in the age of servant. So let us suppose the age of servant be X, and the average age of six members of a family is 20 years. Okay, so that is given to us. So the age increase, so the new age, average age after the servant is included, will be 20 years plus 20% increase, that is 20 years into 20%. 20% will be 1 upon 5. So it will be 24 years. That means the average age after servant is included increases by 4 years. So according to question, 6 into 20. So the same formula again we are using here, that is sum equal to average into number of observations. So 6 is the number of family members before servant was included, and 20 is the average. So 6 into 20 is the years. Okay, and plus x, that means servant age is also added, and 7 into 24 also shows us the 7 members and their respective ages sum added together. Okay, so on simplification you will have 120 plus x equal to 168, and that is x equal to 48 years. The correct option here will be D, that is 48 years. Let us move on to next problem, that is problem number 17. So the average weight of 9 boxes is 61 kg. So we have 9 boxes and their average weight is known. So if 3 boxes having an average weight of 70 kg are removed, then what will be the new average weight of the remaining boxes? So we have 9 boxes and their average weight is 61. And now I remove 3 boxes out of 9, and the average weight of those 3 boxes was 70 kgs. And what will be the average weight of remaining boxes? New average. So the average of 9 boxes is given to us 61 kg, and the 3 boxes having an average of 70 kgs are removed. So that means deviation equal to 70 minus 61 into 3, that is 9 times 3. So the new average weight of remaining boxes is going to be 61 minus 9 times 3 upon 6, that is 656.5. The correct option here will be option number C, that is 56.5. So moving ahead to question number 18. So the average height of 40 sticks is 156 centimeter. Some sticks of average height 162 centimeter are taken out. If the new average height is 150 centimeter, then how many sticks are remaining? The average height of 40 sticks is 156 centimeter. Let us take some sticks that to be x. So now according to the question, 40 times of 156 minus x into 162 is equal to 40 minus x times 150. So again, the same formula is used here, that is sum is equal to average into number of observation. And when you simplify this, you will have 40 times of 156 minus 150 equal to x times of 162 minus 150, so which is equal to x equal to 20. So the remaining sticks is 40 minus x, that is equal to 20. So the correct option here will be option number B, that is 20. Let us move on to next problem, that is problem number 19. Average marks obtained by 19 boys of a college is 48. If the highest and the lowest marks obtained are removed, then the average reduces by 4. What is the average of highest and lowest marks obtained? So in this question, there are 19 boys and their average marks is 48. And if the highest marks scored and the lowest marks scored are removed, then the average reduces by 4. Then what is the average of highest and lowest marks obtained? So there are 19 boys, their average is 48. So after removing 2, that is highest scorer and the lowest scorer, so the average marks is 44. So the deviation is minus 4 and the here deviation is minus 2. So the sum of highest and the lowest marks is going to be 19 times of minus 4 plus 44 times of minus 2, that is 164. So the average of highest and the lowest marks will be sum upon 2, because sum is already computed here. So 164 upon 2, that is 82. So the correct option here will be option number D, that is 82. Let us move ahead, and now we are going to see problem number 20, that is the last problem for this lecture. So the average of PQRS is 30. If the average of P and Q is 12, then what will be the average of R and S? So according to question, the total sum of PQRS. So the formula that will be used here is sum equal to average into number of observations. So number of observations are 4, PQRS are 4. So the sum is going to be 4 into 30, that will be 120. Sum of P and Q, it will be 2 into the average, that is 12 equal to 24. So the sum of R and S is going to be 120 minus 24. So we are subtracting this and this. So we get sum equal to 96. So the average of R and S is going to be 96 upon 2, that is 48. Therefore, the average of R and S is 48. So the correct option here will be option number C. So that was all for this lecture. And in the next lecture, we are going to see more previous year questions. Until then, you can practice all the questions. And I will suggest you to try to solve these questions once again by your own. Thank you very much.